All right, so here we go to demo two, where we're going to build a perfect cube in perspective using the tools that we've already learned. And we're going to introduce the new concept of using measuring points and measuring lines to help us understand this concept. So, just like with the perfect square, we need to start off by giving ourselves a front edge of our cube. So we're going to want a vertical, and we're going to want two converging edges that go to both of our vanishing points. All right. So I'm going to start off. We'll just do black for our front edge so we know exactly where it is. And we will make it, let's put this cube starting right here. Okay. So I'm going to go a little over our horizon line. It looks like we're almost like immediately halfway. Yeah, we'll just go over the horizon line here. Okay. So things to note. This right here is the base of that edge. So this is like the nearest edge facing us um, towards the picture plane. And that is basically the equivalent of this corner here at our station point. And any diminishment I go from this edge to these vanishing points will go at the same degree as this is, so the same turn as this is, as if this cube or this angle is being viewed from above, like a drone shot. All right, so let's do our right edge. Okay, so I'm going to go from vanishing point right until I meet that corner. Okay, and I can go ahead and do the top as well, right up here. All right, and then of course our left edge, so we'll go blue here. Okay, and here. And we can draw through, it's fine. All right, so now I have basically this wall that turns at a 90 degrees and then converges off into infinity on our horizon line, meeting our vanishing points. And I know that this turn is 90 degrees and that it's oriented at the same rotation as this 90-degree tool from our vanishing point. Okay, so I know that I can come down here and say, okay, well, that's 45 degrees. But what I need to do is can I find this length and this length at the same length as this edge? Remember, a cube is not just like a square where we've got four sides, say, for instance, that are equidistant, but all sides are equidistant. Okay, so I need to find the length of this front edge and make it comparable to these two diminishing edges here so I can find how deep into space that goes to be an accurate cube. All right, so to do that, we need to use measuring lines and measuring points. And so I want you to think of this as if I were to take these two walls and unfold them until so it swings from this middle edge that's facing us, and this side swing forward until they run perpendicular with our picture plane. Because then I can say, okay, well, if I measure this and then measure this and they're equal distance, and then I go up here like this and then rotate it back into the appropriate degree, then I'll know where that diminishment belongs. All right. So to find that, we need to use measuring points. Okay. And to get accurate measuring points, if I start from my vanishing points, so we'll say vanishing point right, and I have this length until it reaches the station point. So if I go vanishing point right, I have this length, and I were to rotate it up to the horizon line from the vanishing point, so just a complete rotation like this until it meets the horizon line, then I can find my first measuring point. Okay, so this length of line and the line from this vanishing point to this measuring point here are the same. Okay, now the way I find it is I like to use radials. So if I'm in Photoshop, so if I use this elliptical tool and I start it here at the the vanishing point right here. So if I origin it there and I constrain it to a circle, then I can expand it like this, right? until it hits my station point right there. See that station point? Boom. So that edge hit that station point right up there. And if you look, it creates an even radial like that, okay? So it's just like I'm hinging from my vanishing point all the way up until it meets the horizon line, and that creates this MPR, so that's measuring point right, okay? So, and that's why it's in red. So right is red, left is blue. So you notice that our measuring point right is actually left of center vision, okay? It's gonna fold over here, and then our measuring point left, using the same technique, is gonna fold over here. These are not equidistant, of course, because our two vanishing points are not equidistant from each other, okay? So I have to hinge from this one to send that up there, and I have to hinge from my vanishing point left and rotate it up to the horizon line. And so I get my two measuring points, measuring point left and measuring point right, right? And so I think of this like everything that I need to measure that's on the right side of our form, in this case our cube, is going to use measuring point right and vanishing point right. Everything that's going to govern our left side of our cube is going to use vanishing point left and measuring point left. Okay? So that's pretty easy to understand. Okay. So the next thing we need to do is basically like if we were to put a ruler or some kind of a straight edge up against this corner, we could use the top corner. In this case, I think the bottom corner is better. So I'm going to go ahead, switch to orange here like this. And I'm just going to use this line. Since I already snapped this line to the bottom or the corner of our developing cube here, I'm just going to use orange, and I'm going to run across this line here at the bottom. I guess I probably better switch to the correct tool. So I'm just going to run across the bottom here, okay? All right. So I know from this distance it's hard to see, but here we have an orange line across the bottom. And it looks like I kind of missed that one right there. Didn't quite get that, so let's tighten that up just a bit. In the beginning, imperfections are kind of like negligible, but the more complex you get, the more these things start to get a little weird. All right. So I'm just going to snap this here. So we had just so we can snap it if we need to. Okay. So right there. Uh-oh. One of those was our center of vision. Yep. That one was our center of vision. All right. Okay. Oof. Okay, there we go. Now we're good. All right. Our eye line. Okay. So those snapping tools make it useful. All right. So we need to find this length of line on this measuring line. Okay. And if you remember, we'll go back up to our square demo here. So we want to be orange. Okay. So if we come up to, and we have our square here. So this is a uniform square. And we'll go ahead and we'll stroke that. So edit, whoops, right here. Okay. Edit stroke, and we'll go with 3 at this one so we can see it a little bit better. All right. So we have this cube here, right? So pretend this edge right here is the edge that's touching our, or that's the most closest to us on the picture plane. And we're trying to find this length. Now remember, this length and this length are the same, right? And so this is like that cube that's unfolded. So the easiest way to find this length and this length is, again, with our 45. So if I come up here to the top of that line, and if I hold shift in Photoshop, I can constrain that to a 45 degree and get there to that line. Notice there, it helps me find this distance, right? From this origin point here to here. So I can use that same principle with my measuring line. Okay? So that creates a very, very valuable way to measure a cube. So all I need to do is, if I'm at the top of this line here, and again, if I hold shift and I constrain it to 45 degrees, all the way down until it hits my measuring line. So you can see this ML measuring line right there. I get this point here. So that means that this edge right here and this distance along the measuring line are the same length. Okay? So again, I've unfolded this edge over here and swung it out until it's flat against my image plane. Then I've gone ahead and I've drawn a 45 degrees so I can measure that line. So let's do the other side too, because we want to be able to find this one over here. So I'm going to just do 45 degrees until it hits across the measuring line. Okay, right there. All right. So now, again, I have these measuring points measuring point left and measuring point right. Remember, I swung that perspective line up until it hit the horizon line. So now, if I go from measuring point right through the right side until it hits this right here, this intersection. So if I go there until it meets that, that's going to create our measuring line. So I'm going to go right through here until it meets this point. I don't actually need to intersect through it. I can just meet it right there. And then I'm going to go from measuring point left to the left side of my measuring line. So this is left of center until it hits right there. So those two meet. Okay. So now what you can see is these lines right here that go to our measuring point, and then they cross our perspective diminishment right and left. If I go vertical on those will create the accurate distance. So it's like I unfolded those walls until they became perpendicular to our image plane. I found the length of them, and now I'm going to fold them back, or I'm going to rotate them back and use that measurement. So with that, I can go with the black line. Let me come in here, and I can just get to this where it crosses that edge, and I can go vertical with that line until we get to the top. And then again, vertical with that line until we get to the top. All right, so that creates a perfect cube in perspective based on the degree that we have turned from the station point. So if I come up here, and let's go ahead and just take my line tool, and I'm going to just thicken it up a bit. So we'll go 5 so you guys can see this. And I'm going to go straight down the middle here. Then I'll go across here like this, and then straight up like this. And I can draw through the back as well now that I have these corners. So if I want that, see-through array, and we'll do that when we get to our technical drawing of our vehicle. But for our purposes here, we just need this. So if I hide like all of our measurements and stuff, we can now see that that is a cube in perspective space on our ground plane relative to where our horizon line is. It is turned to the same degree that I've turned this right angle tool. So this is vanishing point over there. I have a couple of tools here that I use, which are my rubber band tool here. It's almost like if you take a couple of push pins and plant them on your vanishing points, and then use those with like a pencil suspended between a rubber band and those 2 points. Then it like allows me to create diminishments. So if I use this here, you can see this, see how it like moves like that. I can see that, yes, that is accurate. And it allows me to find a lot of details on this stuff. So if I wanted to create, various elements here. So yeah, that works really well. In addition to that, I've also created one that's my measuring points rubber band. So that allows me to come through. If I turn this layer back on here, you can see that I can use that to reference these measuring points, so I know where these things are going through. So just some useful tools that I do that kind of make it a little bit quick and dirty for me, and yeah, without having to get too hairy on this stuff. So yeah, so that helps a lot. Okay, so again, let me back out here. We have a perfect cube on the ground plane in perspective, and it is the same degree of turn as this right angle tool from our station point. So it's diminishing to these vanishing points. And we used measuring points and a measuring line to get that in there. Okay.